Hello everyone, my name is Petteri Kivimäki and I am the CTO of Nordic Institute for Interoperability Solutions, NIIS for short. The topic of this talk is the message room concept, how to implement the publish subscribe pattern without a centralized message broker. Before diving into the topic, I'll give you a little bit of background first. The message room concept was first introduced a couple of years ago by Kristo Vaher, the former Estonian government CTO. Originally, the message room concept was an enabler for implementing proactive digital public services. In practice, that means that the government would proactively suggest public services to citizens instead of citizens having to apply to them. Since the government has a lot of information about its citizens, like you and I, the government should know when a citizen is entitled to a public service. Proactive digital public services means that the government starts actively offering services to citizens when they're entitled to them. Implementing this requires new kind of interactions between public authorities, and the message room concept was developed to make that possible. However, the message room concept is not only about public services and public authorities. Technically, it's an implementation of the publish subscribe pattern without a centralized message broker. It can be applied to other use cases too, and it can be implemented using various technologies. In this talk, first I'm going to concentrate on how to implement it using X-Road. That's the open source software used as a national data exchange solution in Estonia, Finland, Iceland, and many other countries around the world. However, I'm also going to show that it can be implemented using other technologies as well. But first, I'm going to give you a short introduction to X-Road to understand the details a little bit better. So, let's start with the organization that's responsible for maintaining and developing X-Road, NIIS. NIIS is a non-profit association which mission is to develop digital government solutions to its members. Currently, NIIS has 3 members, Estonia, Finland, and Iceland. X-Road and Harmony e-delivery access are the main products of NIIS. They're both open source solutions for secure data exchange, and their main difference is that X-Road is mainly for national data exchange, while Harmony is for cross-border data exchange between the EU member states. In this presentation, I'm going to concentrate on X-Road. X-Road is an open source software and ecosystem solution that provides unified and secure data exchange between organizations. X-Road is licensed under the MIT open source license, and it's a digital public good verified by the Digital Public Goods Alliance. According to our information, there are 22 X-Road ecosystems worldwide. In the countries where X-Road is used, there are over 370 million inhabitants. The X-Road community has over 3,000 members from over 140 countries. Based on these numbers, you can say that X-Road is a truly global solution. Here you can see the X-Road world map that includes all the countries where X-Road has been deployed according to our information. However, not all the countries are using X-Road as a national data exchange solution. In some countries, X-Road has been deployed by a private company for some specific use case. For example, that's the case in Germany, Japan, and UK. The most typical way to deploy X-Road is on a national level. In that case, X-Road is used as a data exchange solution between different types of organizations and sectors, public authorities, private companies, and so on. In many cases, data exchange solutions are business domain or use case specific, but that's not the case with X-Road. However, there isn't any reason why X-Road couldn't be used for a business domain specific implementation as well. X-Road is fully data format agnostic, and it can be used to exchange any kind of data. X-Road is based on a four-corner model, which idea is that the information systems do not communicate with each other directly, but through unified access points. In the X-Road architecture, the access point component is called the security server. The security server guarantees the interoperability and security of the data exchange by providing several features out of the box. For example, message routing, message logging, transport layer encryption, and authentication of the data exchange parties. Each organization has a security server that's connected to the organization's information systems. When the information systems need to communicate with external systems, all connections are established through the security server. In other words, X-Road is like a secure peer-to-peer network for data exchange between organizations. This diagram has been kept simple on purpose, and in real life, a single organization can have multiple security servers, and a single security server can be shared by multiple. X-Road is not only a technology, but it has its own governance model too. X-Road operator is an organization that owns the X-Road ecosystem. The operator defines the rules and policies and decides who's allowed to join the ecosystem. For example, in Estonia and Finland, the ecosystems are open for all kinds of organizations. To become a member of the ecosystem requires agreeing with the rules and policies and completing the technical onboarding process. During the onboarding process, the identity of each member organization is verified by a trusted certificate authority, and a signed certificate is issued to each member organization. Also, each organization gets an X-Road specific identifier that's included in the signed certificate. The signed certificate is used to authenticate the organization and to sign all the messages sent by the organization during data transactions. Instead, a member identifier is used to identify the organization during data transactions. A member organization can be a service consumer, service producer, or both. And each organization is in full control of their own data, and getting access to the data requires a service agreement between the message exchange parties. Trust service providers are organizations providing trust services to the ecosystem. They can be commercial service providers or hosted by the X-Road operator. It's up to the X-Road operator to define which model is used. This diagram illustrates how data exchange in the X-Road ecosystem works. Data is always exchanged directly between the service consumer and service provider. Third parties don't have access to the data. X-Road is fully data format agnostic, which means that any kind of data can be transferred using X-Road. However, the X-Road architecture has some centralized components too. The central server is the member registry of the ecosystem. It holds information of all the members and their security servers. The information is shared with the security servers through a mechanism called global configuration. The global configuration is the phone book of the ecosystem. It provides the security servers with the information of all the members and how to connect with them. Thanks to the global configuration, the security servers know who are the trusted members of the ecosystem. However, fetching the global configuration doesn't play an active role in the data exchange process. Instead, it's fetched in the background, stored locally, and the local copy is used during the data exchange process. I am sure that you are all familiar with the publish-subscribe pattern. Therefore, I'm not going to spend much time explaining it. In general, it's an asynchronous data exchange pattern that decouples message publishers and subscribers, or data producers and consumers. Instead of connecting to each other directly, publishers and subscribers communicate through a message broker. The implementation of the publish-subscribe pattern varies between different solutions and applications. For example, Apache Kafka, RabbitMQ, ActiveMQ, and so on. Typically, the message broker consists of multiple topics that can have one or many subscribers. Depending on the implementation, message delivery can be based on push or pull model. On a logical level, the message room concept looks very similar to the publish-subscribe pattern. When comparing it to a typical implementation, a single message room equals to a topic, which means that each message room has a specific scope. In practice, the security server acts as the entry point to a message room. It means that information systems communicate with the security server that is responsible for all the message room related functionality. Since X-Road is based on a decentralized architecture, the X-Road-based implementation doesn't include a centralized message broker. Instead, each security server acts as a decentralized message broker, which means that the publisher's security server talks to each subscriber's security server directly. In this way, the data published to a message room is always transferred directly between publishers and subscribers. No third parties have access to the data. But how does this work in practice? Let's look at the details through a simple example. In this example, we have a message room for publishing information about newborn babies. There are two hospitals as publishers and the population registry and the social insurance system as subscribers. The very first step is to create a new message room for sharing the events. Hospital 1 creates a new message room by registering it to the central server. As I mentioned before, it's the member registry or the phone book of the ecosystem. It maintains a list of registered message rooms, owner organizations, allowed publishers, allowed subscribers, and registered subscribers. This information is distributed to all the security servers through the global configuration. In this way, all the security servers are aware of all the message rooms and their properties. When Hospital 1 creates the message room, it assigns Hospital 2 as an allowed publisher and the population registry and the social insurance systems as allowed subscribers. Each organization has a unique identifier that is used in the assignments. Once the message room has been registered, the population registry and the social insurance system subscribe to it. When Hospital 1 publishes a message to the message room, it sends or pushes the message to each subscriber separately. In other words, publishing a message consists of multiple one-to-one data transactions between the publisher and the subscriber. No third parties have access to the messages. Now you're probably thinking that couldn't anyone publish a message to a message room since the information about the rooms and their subscribers is available to every security server through global configuration? The answer is that yes, anyone could do it, but the message wouldn't pass the verification done by the subscribers. Every message is signed by the sender using the sign certificate that includes the sender's unique identifier. The same identifier is included in every message as well. Therefore, the subscriber can verify that the identifier in the message and the identifier in the certificate match and the publisher is in the allowed publishers list. In this way, it's possible to verify that the message was published by an authorized publisher, the publisher is who it claims to be, and the message content hasn't been tampered with. Similarly, it's possible to verify that only authorized subscribers can subscribe to a message room. The verification is done by the central server when registering a subscription. So, this is how the message room concept can be implemented using X-Road. However, currently, this is just a concept since it hasn't been implemented yet. The plan is to implement it in the next X-Road major version, X-Road 8. As I mentioned in the beginning, the message room concept can be implemented using other technologies too. There's nothing X-Road specific about it, although X-Road provides several features that support the implementation. The implementation requires that the data exchange parties can be identified and authenticated, and the security and non-repudiation of the data exchange is guaranteed. In addition, there must be a list of registered message rooms, owner organizations, allowed publishers, allowed subscribers, and registered subscribers available to the data exchange parties. For example, the implementation could be based on self-sovereign identities, SSI. The data exchange parties would be identified using decentralized identifiers, DIDs, and the required information would be maintained in a DID registry based on a distributed ledger. In that way, all the necessary information is available to all the data exchange parties, and the data exchange parties would be authenticated using verified credentials. Of course, the actual data exchange protocol needs to be defined too, so that the publishers and subscribers know how to communicate with each other. In the case of X-Road, the protocol is already provided by X-Road. Nevertheless, this example shows that the concept can be implemented using other technologies as well. It is not X-Road specific. If you are interested in hearing more about X-Road or the message room concept, don't hesitate to contact me. Thank you for listening and watching this video.